So, first of all, a little bit about myself. I've been doing monitoring of enterprise applications for a bit over 20 years now for companies like Wiley and Dynatrace, um, Quest Software, and Mercury Interactive. And I joined a company called Signal FX, which had a streaming real-time take on monitoring, and that's the company that Splunk bought last year. So now we're part of Splunk, and Splunk has a initiative to do more observability, more real time, more bring data in from anywhere, and then being able to apply it to many different use cases. So I wanted to show you, if you guys haven't seen like a streaming architecture around monitoring, it's a really cool solution. So I wanted to just go through a couple of background slides to kind of, when I first saw the solution, coming from things like Dynatrace and CA Wiley, most monitoring tools I've used in the past have the same architecture. Same with all the open source ones right now, like Prometheus and Graphite. They're all based on collecting some data and putting them into a database, and then querying the database to drive dashboards and then drive alerts. That was fine when we had a certain contained number of things to monitor, like when we're doing our monolithic Java and .NET monitoring using bytecode instrumentation. But now we move to Kubernetes and containerization, and when you go to cloud, you want to auto scale and you want to architect in microservices. So all these innovations are creating a lot more things to monitoring and a lot more data to monitor. So the streaming architecture and the real-time aspects really is appropriate. So I wanted to go through how we got here, and also kind of show you about how we set up the Signal FX monitoring solution. So, well, first of all, what is Signal FX? It's a real-time monitoring solution. And when I say real-time, we mean real time, which is down to 1 second resolution at scale. This is a snapshot of the architecture. It's based on a bus architecture. So instead of having a batch-oriented database-centric design, we went to streaming, which is really great because when data comes in one side, we have it hitting a dashboard or firing an alert, usually within about 1.5 seconds. And that's consistent independent of load. So there's all these use cases that enables. I'll get into those. So 1 second, so the real-time aspect, and also just like Splunk has the same philosophy, which is we should be agnostic to how we gather the data. Not only are our applications becoming more cloud oriented, but they're also hybrid, and data's coming from multiple locations. So we should be able to collect infrastructure and application data both on-prem and also in multiple clouds. So that's really was the design philosophy from the beginning. The streaming architecture with streaming analytics built in enables us to do things in real time. And really, the really cool part is the streaming analytics right here, because in the past, when you choose which metrics you want to put on a dashboard and how you want to fire your alerts, it's usually has to do with how long it takes for the data to get processed, and you can't really do much post-processing of the raw metrics. So I have alerts based on, let's say, CPU utilization, which may or may not be a good alert to throw. So what's been happening is there's a lot of alerts, and not all of them are actionable. So by having analytics built in stream, we can do things like process the data in real time, make it more meaningful and more actionable, which has been really great. This is when I first saw this architecture, having known the previous tools that I've used, I thought, okay, this will enable me to do all these use cases I couldn't do before. And then also do things like, hey, auto-generate my dashboards for me. I don't want to spend a lot of time just curating a set of dashboards. So we'll get back to this architecture, but the technology it's kind of a cool background. The technology came out of Facebook. 3 of the co-founders of Signal FX, this is way prior to the Splunk acquisition, they were the original monitoring team at Facebook, and they developed a metrics monitoring solution that's still in use today at Facebook called ODS. And a couple of lessons they learned, because they hit the scalability issue like really soon. This was back in the days when Facebook only had like 500 million accounts, so they were tiny back then. But they were growing very, very quickly. And a couple of lessons they learned is that, you know, the having a proprietary agent, that heavyweight agent that's in charge of collecting in, you know, one way of doing things, that's not really, I mean, you got data coming from all different sources. And we're also going to talk today about how to optimize your spend, let's say with cloud providers like AWS. And so we have data coming in, you know, performance data, capacity data, we have cost and usage data coming in. They're coming in from different places. So you really want the data collection part of a solution to be general and agnostic, because instrumentation should be commoditized. We really should focus on what we're doing with the data, how to make it more actionable, more insightful, in other words. That's where the value shifted to data analytics, and that's why we have real-time analytics built in too. That's a very important part of this approach, this type of approach to monitoring. So what they did is, after they decided, hey, Zuckerberg has enough money, they decided to found their own company. So they re-implemented the approach they were using at Facebook, and they founded SignalFx about 6 years ago. The view that they had of where application architecture is going kind of looks like this, where instead of having these monolithic pieces that maybe get updated, you know, once a quarter, once a month, that sort of thing. When you go to microservices and containerization and Kubernetes and even things like Lambda and Fargate and all those new services that we have access to now, your applications are becoming far more dynamic, and they have a lot more pieces to add up to become your application. So like, for instance, these could be containers or hosts or whatever, and see some of them are offline. They can pop up in a couple seconds, do some work, and then you know, rewind down again. So if we had a time lapse kind of movie of what an application architecture looks like nowadays, these would be twinkling like stars. They're constantly coming and going. So the old approach where I have more of a static architecture and I can place an agent in a certain place and it can do the work, that quickly is becoming less and less useful. And I ran into that like when I was at Dynatrace and Wiley, where people say, okay, well, I'm using Kubernetes. Where do I put the agents? In other words, it's harder. How do we license these agents? So there's a lot of friction that this was causing in the commercial monitoring space. And also, where this dynamic architecture is living, it's not just a single cloud provider now. I mean, AWS definitely is the leader, but we have a lot of our customers and clients using multiple clouds, and also some of the applications still on-prem. So once again, you got data coming from multiple locations, and you have constantly changing infrastructure. And by the way, that's encouraged. I mean, a lot of the advantage you get from using microservices is be able to, you know, launch code into production independent of other teams that are working on other parts of your application. And also when you use containers, I mean, you want to be able to spin up and spin down containers quickly. That's what they're really good for. So the problem is that monitoring always kind of is an afterthought. And so to really fully take advantage of all these new innovations, the ones I mentioned, you really do need to have a way of keeping up. So the whole approach, if you peel back the layers, it's the feedback loop. You can only launch into production as fast as you can monitor it, as fast as you can have that feedback loop to tell you whether it is working or not. Otherwise, you're just going to increase the number of errors and then problems. So that's really the problem statement. The other one is how code gets in production. The old way, of course, is more monolithic releases, throwing over the wall to operations, and then launching these changes on a curated set of servers. These are the proverbial pets instead of cattle, right? You know, you guys heard that expression that these have names. They're usually in some CMDB or spreadsheet somewhere. Operation curates those so they hate changes. The new world is you have, let's say, a bunch of microservices. You have your teams that are the right size, like the 2 pizza teams, or the right size of a development group is ones that you can feed with 2 pizzas. So you have all these guys launching code into production asynchronously and more often. And also, in a lot of cases, the coder is responsible for their code in production. We've seen that more and more. So the audience for any sort of monitoring or visibility is more than just operations nowadays. It extends to other teams, like your developers. And then you have all these releases being launched once again on this dynamic ephemeral architecture. So that's the problem statement. I ran into this using older approaches to monitoring, and it's really the number of use cases I could do help customers were decreasing. So that's why, you know, when I saw signal effects, I went, oh, that's an interesting approach, which is I want to show you that today. And these changes to things like DevOps, automated DevOps, faster releases, the use of microservices and containerization, Kubernetes, and even things like function as a service. Like at the last AWS reInvent, I think 77% of the sessions had Lambda as a keyword in there. So all this is, I mean, a couple years ago, these were in the 30 and 40%. So this is like 4 waves hitting the beach at the same time. It's a pretty big change. It reminds me when virtualization first came out and how that changed how we architect and deploy solutions. So now the problem that I'm trying to work towards right here in this talk is that most monitoring tools like logs, traces, and metrics, those are the big 3 pillars of observability. They each have their own advantages. Like logs, you can go really deep and collect all that information. Traces helps you like see all your microservices and how they relate to each other. So when you have an error reported by one service, you know like what's the upstream and downstream services, and you'd be able to find out exactly where the error is coming from. Kind of the expression I used to have is like sometimes when you have an error, it's like the car hit the tree, and then the next step you found the error. So it's not always where you think it is. So it's good to have traces to kind of show you how the transactions are flowing through your application. And then metrics are always great because they're the lightest weight, fastest way of getting telemetry or knowledge about an application. So all 3 together, that's where like most of the articles you read on observability, they all talk about logs, traces, and metrics. Okay, so that's any monitoring solution needs to have some capability in each of these. The issue is that traditionally, most of the solutions that are out there, both open source and commercial, are making assumptions about what they're monitoring, which are more the monolithic, slowly changing application architectures, where you have hundreds of things to monitor. And when there's everybody's reading the same articles, we know the advantages of containers and microservices, so we start shifting a few things, re-architecting parts of our application, and we end up with thousands of things to monitor. The thing about containers and microservices and cloud auto-scaling and turning things like capital expenditures and operational expenditures, it's very clear the benefits of them. So you don't have to argue about the benefits of containerization. It's pretty clear nowadays. The problem is now you have thousands of things to monitor. And these solutions trying to stretch to be able to handle that amount of load. But as I'm going to show you, there's an application bottleneck, there's an architectural bottleneck that is a problem, and the problem that I witnessed firsthand. This gap right here is like called an observability gap, where really to take advantage of microservices, containerization, cloud auto scaling at scale, you need to be able to monitor tens of thousands of things that are changing continually, and so that's the problem. And so here's a view of this architecture, which is common for most monitoring solutions, both commercial and open source. Some type of data collection technology. In case of commercial solutions, it's some proprietary agent that if you want to use, let's say New Relic, AppDynamics, Dynatrace, Wiley, you need to use their agent. Those agents collect metrics and other telemetry, and they deposit them into a time series database. And then all your charts and dashboards and all your alerting rules, any automation rules, they're constantly polling or querying back into the time series database. You can kind of see where an architectural bottleneck would come out of this. If the number of writes to this database all of a sudden goes up by orders of magnitude, and we're talking about at least 2 orders of magnitude increased amount of data because of all the things I talked about previously. The reads of this database will not only get slower, but the latency gets more variable. And that translates to, okay, I know there's a problem with my application because I saw the Twitter feed, but I haven't gotten any alerts. And maybe I fix the problem, and then 10 minutes later, I get the alert. Or I have a dashboard that sometimes it takes hours to refresh. And I've actually seen those two use cases firsthand. And this is why there's so how do you get out of this architectural bottleneck? Well, you could put this database in memory, you could shard it, you can do a bunch of things like Prometheus has like sharding built into it, but then you kind of lose end-to-end visibility. So the best thing is eliminate an architectural bottleneck. Architecture really starts to matter when you scale. That's kind of the lesson here. And because microservices, containerization, cloud auto-scaling, automated DevOps processes, they're all greatly increasing the scale, the load, all of a sudden the correct architecture matters. And then also things like another solution is just, hey, just don't read all the data, sample the data coming in. That's a way of lightening the load of your database. And that's what a lot of solutions do. But the problem is that hey, if I look at like every 100th transaction, all of a sudden I'm missing all my interesting transactions. Like if I have something that shows up, this might be an important thing to fix, but it only shows up in a 5% of my transactions, I'm probably going to sample that away. So instead, we really want to be able to have the bandwidth to look at all the transactions, 100%, going through going through your application. And some commercial products like SignalFX, now Splunk, and things like Dynatrace, other ones, they do see the importance of doing 100%. So, but other ones don't. Most monitoring tools out there, when you talk about tracing, they're always sample, and they sample sometimes up front and randomly. So they miss a lot of things, in other words. Okay, so where do we want to be as far as a monitoring tool? We want to be able to straddle this observability gap and be able to take full advantage of these new technologies and be able to handle this amount of load. That's the setup. This is the architecture we came up with, or the founders came up with, where it's the main path through the monitoring solution is completely streaming, where data is never at rest. So in other words, instead of having a time series database in the center of the solution, instead we have a router, data router. All our charts and dashboards and automation rules and alerting rules, they're analytic clients that subscribe to our data router. So you have a publish subscribe paradigm. That eliminates that architectural bottleneck of data at rest and then being queried out of a central location. Of course, you also do want to look back in time. If I want to alert on a service being slow, I want to compare it, let's say, with last week, last month, last year. So in other words, you still want to keep historical data, but you see, you want to like get that out of the critical path. So, and I'll show you a demo now, and this will make more sense. But this is a demo that I saw way back when, which I thought was really cool. So I'll show it again here. I have a microservices based application. You can see right here, it's an e-commerce type application. Each one of these circles corresponds to a microservice. And like, for instance, I have card and checkout and catalog. We're actually generating in this tool, we're generating this automatically by just tracing transactions through the system. And we're also generating dashboards for each service that we discover. So once again, you start giving people that are using these tools kind of an elevated starting point. So this dashboard we're looking at right here is for the catalog service, which is that service right here. And I can see like the number of transactions that I'm processing each second, the normal response time. Since I'm looking at every single one of those, I have a pretty accurate what's normal. I can even start doing things like breaking down the request latency by customer, or in this case, this service is implemented as a containerized application running in AWS. We're using ECS in this case, but this could be Kubernetes and an EC2. This could be Fargate. This could be any technology you choose to use. And you see, we're able to handle this much load on 3 containers. And you see here, we're actually monitoring this second by second, and that's what a streaming architecture will get you. I can We have customers that are using hundreds of thousands of containers, like Yelp is a big container user. And they're routinely run with 100 to 200,000 containers, and we're still able to give them 1 second throughput here. What I'm going to do is in the background, I also have a GitHub repository and a Jenkins server. And so just to show you what we mean by real time and be able to react quicker and be able to find incidents faster, is I just changed the code or updated the code in GitHub, and Jenkins is going to notice the change. We're going to see the release. Actually, we just seen it right here starting, where I can see that this yellow container spun down and got replaced by this pink container up here. So we're actually seeing what we call a canary deployment in real time, where I'm going to test out the new code in one of the containers, and I'm going to leave the rest alone, and we'll see how it performs. So you can kind of see here that, hey, this is not performing as much as I would hope. Where instead of like 500 milliseconds, we're running about 5 seconds. And even here under this chart, we can see these latency spikes starting to appear. So not only the streaming approach to monitoring enables us to start monitoring immediately within 1 to 2 seconds, like this figure right here, this icon is actually an event that we ingested from Jenkins that says, hey, I started my canary push. Then you see that we notice that this container changed. We start monitoring this immediately, and this triangle right here is an anomaly that we actually found based on latencies. And so we see right here in our event feed that we actually found this container latency, because we know how long these responses are supposed to take. So I know right away that, you know, how many standard deviations we're seeing here. And I throw that exception, that alert within a couple seconds. Now, a couple things I can do here. Whenever you get an alert, you could notify people, or you can look for, you know, known issues and do runbooks and all that stuff. I even have another company that Splunk bought is called VictorOps. I even got an alert on my cell phone here that an incident was triggered, and I can go into VictorOps and then check out the incident right here. But for these sort of high-speed use cases where we're doing a DevOps, we're just, you know, putting some code in production, seeing what happens. I probably want to auto remediate this. So in addition to all the ways you can alert by, you know, sending emails, sending texts, you know, pinging PagerDuty or VictorOps or any of those, I can also auto remediate. That's what happened here. Is as part of the alert condition, I decided to go ahead and send another webhook to Jenkins telling it to start its automated rollback pipeline, which is what happened right here. So we see that this is a message from Jenkins saying I started my automated rollback. And then you can see that a second or two later that this container got pulled out of this environment and replaced with the previous version of the code. So this is a use case I really like, because it shows off clearly what happens when you have a streaming architecture. So if you take a step back and you look at what happened here, is we had a launch of code in production. And in this case, let's say this company that this represents, they want to launch code in production at will. So, you know, you want to be notified right away when there's alert happens, but you also want to be able to fix the problem. That gives you the ability to take advantage of, you know, this containerization and changing things in production, auto scaling at will, and always having your finger on the pulse of what's happening in your application, not having to wait tens of minutes, which is pretty normal for this type of load when using other monitoring solutions. So yeah, any questions so far about what we saw?
Yeah, feel free to unmute and ask any questions of Bryan. He's here at our disposal. I love the idea of all the streaming. I think that it's so nice to get away from that whole architecture of polling and depositing data. And
I got a quick question.
Sure.
I'm Adam. If you see me, I don't know. Sometimes when you're sharing a screen, you can't really see. But so for example, at Diagnotes where I work, we run mostly on Fargate and rely on some of that like auto rollback stuff and the health checks that it does. So like if we were doing that, would we see similar things here instead of like your webhook for Jenkins, would we notice when new containers were being rolled out on the dashboard?
Yeah, absolutely. And I do have a customer that's using Fargate for their containerization. And for Fargate, we would just do a sidecar on a Fargate task. But it's pretty much, we standardize on only open technologies for data collection. So the agent that we give to our customers is really based on collectd and Telegraph, but we can use Prometheus and other ways of instrumenting this. The couple of differences that you'll see, and it really is a good question. Like, I know AWS has a lot of monitoring built into it. So what's the difference here? I mean, besides we can monitor multi-cloud applications, which a lot of customers have. But one of the things is the speed that we're working at. We can routinely do 1 second resolution for your telemetry, independent on the number of containers you have spun up at any particular time. The other thing is, I mentioned streaming analytics, is what do we alert on? I could, since I have, let me go back to the architecture, since I have streaming analytics built in, things like outlier detection, rates of change analysis, I can compare now with any time in the past and only alert if it's different. There's a lot of things I can do to make this alerting a lot more meaningful. And that's a big thing. That's a big change, is be able to have full-blown predictive analytics built into your streaming pipeline. That makes when you do have an alerts, it makes it more meaningful alerts, in other words. But yeah, but true, like Kubernetes and Fargate, they have ways of spinning up additional components to handle load conditions and things like that. This is just a little more general approach. Did that answer your question?
Yeah, I think so. I mean, lots of cool stuff going on here. So, yeah.
I know it's a lot also to fit in. This is like, if usually it's the whole hour we get into this, but let me show you what we mean by analytics, because I think it's one of the cooler things. Is here, this is more of a type of dashboard that people are used to seeing, where I have different charts and they're updating at different rates. Like, these are 5 seconds, these are 5 minutes, and the way we set up our system is any dashboard is a collection of charts. Each chart can take data streams at different frequencies, whatever makes sense for your data collection. Infrastructure metrics you might want to do every minute, every 30 seconds, but your application metrics you might want to do every second or even sub-second. So each of these charts will update differently. And like, for instance, here's the number of API calls I've had over the last 24 hours. Here's the rate of change hour over hour. Here's my SLAs, which I'm defining as my 99th percentile. Here we're bringing in AWS information about how many EC2 services am I running on. So now I can calculate the costs. So speaking of that, I know we're talking about cost utilization also. I can take this information, which I'm just getting from another AWS API. Like I said, being agnostic for data collection is a huge advantage. So let's go and look at how many servers I'm running on. So I'm pulling this live from AWS. I know I'm running on 7 nodes. Here's the size of the nodes I'm running on. I can look up my costs for those. So I know my cost per hour and my cost per month for these 7. Like I said, this can go up to 8, go down to 6, depending on the load conditions and how I'm spinning down servers. So now, as, let's say, a product manager rather than a DevOps guy, I might want to do a calculation in real time. I might be interested in something like, show me my top customers using those APIs by how much they're costing me to support them per hour. And I can do that because I can take this information and I can do calculations in real time to divide this by the number of, let's say, API calls that they're using and get the cost per hour, and then rank my customers by how much they're costing me per hour. That's just one way of like keeping, it's nice to be able to use Lambda and Fargate and all these great innovations, but a lot of times when our customers start getting into that, they lose the ability to kind of really assign the cost or really understand how much are they actually saving over the old ways of doing things. And so by having this analytics stage built in, not only can I make my alerts more meaningful, but I can also do things like this. Anything that's a number, metric time series that are coming into the solution, I can do calculations in real time. And I can show you, let me just wind up here by showing you what that calculations look like. So I mentioned that this chart right here is showing me my hour-over-hour growth rate of how much I'm using these, how much my customers are using these APIs. So if I want to see how we're calculating this, because this is actually a derived metric. This is not a raw metric. This is something I'm calculating in real time. So I'll just open up this chart by clicking on it. And so the way this is set up, you remember, think in terms of streaming here, that I have this big pipe. I can have hundreds of thousands of time series coming in, but for any particular chart or automation rule or alerting rule, I want to peel off a subset. I don't want to get the full fire hose, right? I want to pull off a subset of that. So the first thing I want to do is inside this chart is say, okay, well, which time series do I want to bring into this calculation? So this is where I can filter down my signal. And another cool thing to keep in mind is metadata, all the tagging that you do in AWS, that provides really great context to be able to bring together all these pieces that you're monitoring to build up a view of your application again. So like, for instance, here, if I want to filter this by like availability zone or any tags that I put on these resources in AWS, they flow into this monitoring solution. So now I can use it as part of my filtering. So if I want to look at only the calls coming in from a certain region, I can do that too. Because all I'm doing there is I'm filtering down this fire hose in this analytics stage. Okay, so once I have the signal the way I want it, now what I can do is say, how do I want to process the signal? And I mentioned that we built out all these analytics functions, and they all work on stream in, stream out principles. So like, for instance, I can do things like sum across them, do a count, I can do percentile calculations like you saw in that SLA calculation. I can time shift into the past to compare now with any time in the past, do things like standard deviations and rates of change analysis to do predictive analytics. So we wrote a whole bunch of these analytics functions that take a stream in, produce a stream out. That means I can start pipelining them like a Unix command line, and I can continue to pipeline these, and these will work in stream. So these work in real time also. If I try to do this same sort of thing with a database-centric design, it would just add to my latency because I'd have to do queries and also write back to the database for the intermediate results. So here, just real quick, I take stream A, which I already defined by anything with metadata, SF, demo, num calls. I got 28 time series, which I discovered dynamically. I sum across them, and I do a 5-minute moving average to kind of smooth them out a bit. And then I'm going to duplicate line A as line D. So I'm going to create a second stream. And this one, I'm going to time shift 1 hour into the past. Now I have two time series. One is a shifted version of the other. So now for line E here, I'm going to do some math. So math in real time in a streaming monitoring solution. So I'm going to take line D, divide it by line A, subtract 1, scale it up by 100, and that gives me my hour-over-hour percentile rate of change number. And that's one I'm actually showing right here. See, that's the blue eyeball. So in other words, with a streaming architecture and a monitoring solution, I can create derived metrics on the fly that update in real time, and I can alert off of this, not off my raw metrics if I want to. This gives a lot more control. Your alerts are a lot more meaningful to whoever is using the alerts. And you can also do things like, another customer we have is Nike, and they have a bunch of health metrics. Like one is called shoes per second, where they'll take a bunch of infrastructure and application metrics, and they will create a composite metrics in real time. And then that ends up on a lot of their dashboards as sort of an overview. How is my application doing, the overall health metric? So that's how we do this. And speaking of Python, if I, when you look at this view, it's called the builder view. I can click on this view signal flow link, and we see exactly we're building a very Pythonic like a language. We call it signal flow, but it's a domain specific language. And so here, this is exactly equivalent to what you saw in the builder view, which shows you how I'm taking my streams and I'm applying these functions like sum and mean all in real time over the stream using a Python-like language. Okay, cool. So any questions about this?
Yeah, that's really cool. Any more
Yeah,
questions?
really very cool system here. But so let me ask one quick question, and this is kind of a weird, maybe a weird question, but do you have to plan for additional network traffic in your environment? How efficient is it? You know, are there things that you have to think of when you're putting this in?
Oh, sure. So so you have to think in terms of so I'm going to be collecting data from multiple sources, and the metrics I'm collecting. First of all, how do I collect the metrics? Is there some sort of like is there already Prometheus, let's say on a Kubernetes stack? Do I'm already using collectd on my servers? You know, or can I just run a script to collect some sort of telemetry and then post it to a URL? So first thing you think about is how to get at the data. The good thing about not relying on a proprietary single agent is you can get data from a lot of different sources that maybe an agent wouldn't support. On the other hand, you kind of need to plan for that. We you know, as far as our commercial offering, we take collectd and telegraph and we wrap it with a Go language auto discovery wrapper just to make it easier. So you can deposit what we call a smart agent, even though it's not proprietary, it's still open source. And you can put that on, you know, in a Kubernetes cluster, in a Fargate cluster, inside of a container if you want to, because it's very lightweight on a host, and then it generates the metrics for you. And then since now you have access to metrics from many different sources, if you want to do things like this, here we're showing a kind of cost analysis of my EC2 usage. This is something we use internally because we're a heavy user of EC2 to host this monitoring solution. So what do I want to do with that data? What you know, all this data coming in, what calculations do I want to do in real time to make something meaningful out of it? And then how do I want to alert or visualize off of it? So, you know, the advantage is you have a lot more options here, but you also have to think about how am I going to do my analytics, or what should I do? What do I want to put on my charts, my dashboards for the audience that's seeing that, and then back in there about what calculations do I need to do. So there's a little more to think about, but you can see you have a lot more flexibility, and knowing that you can do calculations without worrying about really slowing down your latency or increasing your latency. So you still are able to find problems with your application within, you know, literally seconds, rather than sometimes minutes, sometimes tens of minutes, sometimes take hours, depending on the load going into your application. Did you have something else specifically that you wanted to talk about on that?
No, I think that's a good overview. I was curious, you know, obviously you're not going to spend as much on your database, the database side of things, because it seems like there's a lot less processing going on. Maybe I read that a little bit wrong, but
so in here, like for instance, we chose to use Kafka as a bus, just because at the time it was really one of the lowest latency buses out there. We decided not to use like Kinesis or any vendor specific buses or other technologies. Like for our time series database and our metadata store, we're using Cassandra for that, because the column oriented database was most appropriate. And like I said, we some customers don't want to use AWS, so we can duplicate this very easily in GCP and Azure. This is we provide this as a SaaS solution. And then the analytics, because we want this to happen really quickly, we chose to write this ourselves, using a lot of the strategies that like a financial service app would have, because we're talking about microseconds actually matter here. So so that's how we chose to do it. We're hosting this in AWS, but we're not using a lot of those like Kinesis and Lambda in order to drive this. I mean, you could duplicate this using Kinesis and Lambda for your alerting and your and also your analytics, but this is really high performance type of computing architecture in here.
So let me make sure I understand. Is the streamed data coming across out of whomever's cloud into your cloud that then gets analyzed on your system? Or does it, okay, gotcha.
So we chose again the SaaS path just because like when I was working with like CA Wiley and Dynatrace, most of my time as a field engineer was just care and feeding of the database and of the servers. And there was a lot of administrative overhead to keep this thing humming. And that's another nice thing I like about this approach is that we have an operations group handling this, keeping it humming, where all you have to do is point your data sources at a REST endpoint, a URL. And as long as it's a JSON format, we can ingest it. That means data can come from anywhere. It can come from on-prem. It can come from other clouds, come from different availability zones within the same cloud. It's very flexible that way. So of course, another constraint is you have to be able to send data over the public internet in order to get to a SaaS solution. So that's a trade-off too. But like I said, we have like PayPal as a customer, so they're using us for this. So there's a lot of precedent there for being able to do that.
Yeah, cool. That's. I just wanted to make sure I understood exactly how that works. So.
Yeah, and just to kind of show you, like, here's some dashboards we created for our own use about, how much am I spending on demand instances of EC2 versus reserved instances. This is from an actual environment. This is how much we can save if we drive this needle a little bit closer to more reserved instances. We can also keep track of this, and this is using the exact same streaming architecture I just showed you that we used for a monitoring application. But now we're just, for the calculations, we're just doing things like, hey, let's look at my utilization here. Do I have any underutilized things that I'm paying for? And since we have access to the CPU and the memory use of every resource in AWS, we can say, hey, this one's not really being used. So it's a T2, so how much is that costing me? In other words, so it's really nice to be able to do cost analysis by also bringing in performance information. So in other words, like I showed you before, we were, in let's see, there was this one. Let me close this chart. So in this case, I am interested in the performance of my application, but I'm also interested in SLAs. But I want to know how much it's costing me to keep these SLAs going. And so that's why I'm able to bring in information from different sources. Like, how much I'm running on, how much it's costing me, and then doing that calculation using that streaming analytics language, signal flow, doing that in real time. And then, like I said, for this particular user of this dashboard as a product manager, this might be the most important thing. I might want to alert off of this to create an alert that's real easy. You just hit this bell icon. And anybody can do this, including the users of the application. And then I can just go ahead and create the alert to watch this for me, and I can say, hey, if this suddenly changes, send me an alert or post to Slack or whatever the appropriate thing to do is. Cool. So I hope that was a kind of a useful overview of how a streaming approach enables you to take advantage of containerization and cloud auto scaling and dividing your application into more granular parts, but still being able to pull it all together in real time.
Yeah, no, thank you so much, Bryan, for being here with us. I think everyone who's not on a camera right now is probably giving you a giant round of applause.